Hi. In the previous video, we looked at internal data communication between tasks in async I/O. In this video, we'll be looking at communicating data between a client and a server using network protocols. So we've covered how async I/O works and a bunch of tools that can be used to manage the execution of multiple streams of code. That's all great, but what about doing some actual I/O with it? The primary motivation for people to use asynchronous I/O is when writing network clients and servers, although that's certainly not the only possible use. So not only does async I/O make network communications efficient, it also makes them easy. Here, we have the code for a simple client-server pair of programs. They just read and write the same few bytes over and over, but they also serve to demonstrate everything needed to communicate across the network. There should be little about the client that is mysterious. It runs only a single task, which uses async I/O's high-level API to open a connection and then send and receive data through it. The server is able to handle simultaneous connections from many clients at once. Because the start server coroutine we called launches a new task to run our serve coroutine each time a client connects to the server. Each task has the job of handling a connection to a single client, so the serve coroutine is almost as simple as the client coroutine. There's a little bit of extra code to handle a connection reset error, which is the exception that gets raised if the client suddenly disconnects while the server is trying to read data from it, and a little more to handle the class where the request is an empty string, which the readline coroutine can only produce if the client has closed the connection in a less precipitous manner. In both cases, we want the server to stop worrying about that particular client, which we can do simply by returning from the client handling coroutine. The task running the coroutine finishes, and that's that. In the launch coroutine on the server, we called another coroutine called waitClosed. That pretty much does what it says. It waits for the server to be closed. Without that call, our launch coroutine would immediately terminate. And since we used run until complete, the whole program would terminate immediately afterward. That would happen because start server launches off a background task and then returns, rather than managing the server directly. And that's about it. There's a lower-level communication API that async I/O provides. But for the vast majority of cases, the lower-level API is unnecessary. Async I/O makes network communications simple. In earlier videos of this section, we learned about coroutines, data exchange between coroutine tasks, and asynchronization. Now we've seen how to get a payoff from all of that by using those tools to write a network client or server. In the next section, we're going to look at various parts of Python that can be redefined within our program source code and how to use them.